Hello and welcome to my first video of SolidWorks trainings. In this video, I'm going to show you how to design this gear which is broken inside, and it's belongs to this device, this kind of jack, a hydraulic jack, and we are going to design and 3D printed it with PETG, and I will show you how to 3D print, how to make a G-code and send it to 3D printer. And first of all, I'm so sorry about my English, my language. Let's jump to the computer to see how to design this gear. So we are in SolidWorks. Let's make a new assembly. Close it. Cancel. Design library. Click on toolbox. Choose ISO. Choose power transmission and gears, and bring some spur gear into the scene. I do pre-assemble this gear before recording this video, so what I'm gonna do, I'm gonna cancel it. Let's bring it again. I'm gonna OK it, and here I choose default, and if you firstly bring some spur gear into the scene, you will see this kind of gear. So let's change the parameters. Right click on this spur gear and choose edit toolbox components, and use the default gear which is bring from design library. So let's hit it again, edit toolbox component, hit Ctrl 8, then we will draw we will choose a sketch and draw a circle at the middle of the origin, or we can choose right plane and draw a circle as our broken gear diameter, smart dimension, and choose 55.5 millimeter. This is the diameter of our broken gear. So let's go back to the gear at the toolbox component, and the number of gear teeth are 43. The pressure angle is 20 degrees. The face width, which is 9.8, and the hops style, I don't change it. Diameter shaft, I'll choose 3 mm for now. I don't need 3 hole, and Ctrl 8 again. So we should change this module size to 1.25 to match our gear diameter. So hit OK. Now we can hide this sketch, and our gear is ready to bring it to the new parts section to draw and sketch the other part of our gear. So choose new parts and go to the design library and bring the gear we are created with right now and make choose yes. Just left click and choose yes. So here we can reshape this gear to our broken gear. Select this face, go to the sketch, new sketch, and choose make a circle. We are going to sketch the lower part of the gear. So draw a circle, smart dimension, and put the number of this diameter. It's 46.4. Hit OK, and we don't close this sketch. Go to the extruded cut, and we are going to cut 3mm inside. Choose this inner part, sketch, new sketch. Then we are going to draw another circle, and the circle diameter is, and let me see, 23.8. Hit OK, and now we could go to the futures extruded boss and extrude it about 8.5mm. Hit OK. Now select this part, this face, go to the sketch, new sketch, draw another circle, and the circle diameter is 10mm. Smart dimension 10mm, and choose center line, draw a center line here, and the distance between these two is 2mm. Hit OK, select this line and mirror entities, select about this center line, hit OK, and then we can trim this to OK. Let's close this sketch. We're gonna come back to this one, and let's work on the other side of the gear. We are going to select this face, Ctrl 8, and new sketch, draw a circle, smart dimension, it's 16.5. select extrude boss and extrude it 5mm. Hit OK, select this face again, sketch, new sketch, draw a circle, and the diameter is this diameter is 12mm, and extruded it about 11.7. OK, select this face, sketch, and draw a circle again, and the diameter is 9.8. It's extruded about 2.5 millimeter. Sketch, new sketch, and draw the last circle, and the diameter is 6.5, and extruded it about 4.5 millimeter, and we're done. So now we are going to back of the gear, select this sketch, and go to the future and extrude cut, and cut it about 20 millimeter. Yes. Now turn around, and here we should draw the last circle to the size of the shaft, and the shaft diameter is 3.2 millimeter. Go to the extruded cut and through all, cut it through all, and we are done with the design. Now go to the file, save the file as gear, and again we are going to save this as STL file. Again, save as, and choose STL and the name of gear, hit yes, and all bodies. Okay, so let's go to the new folder, and the STL file is this one. Let me see. Yes, this one is STL file. So drag and bring it into the Bambu Studio. To create our G-code and send it to our 3D printer. Now I want to print it this way, so choose auto, or you can choose lay on a face and select this face to this orientation, and because I have a Bambu Lab A1 mini, and I'm going to use my presets, filaments, and I choose PETG, and because of the strength of this piece of gear, I need to choose the height of the layers, 0.2 millimeter strength, and also I need to choose enable this support to have a support under, and hit slice plate. and it took about 1.5 hours to print, and about 23 grams of PETG filament. I can send it directly to my 3D printer, which is offline right now, or choose export plate slice file and export the G code into my desktop here, and put it on a micro SD card and print it on my machine. Thank you very much for your attention. I hope you learned something about the design and working with SolidWorks. And the purpose of this series of videos is to learning about the SolidWorks and creating the broken part and designing the broken part which can't be found on the market. So this is the broken gear which shaft gets in here, and as you can see, this tooth was broken. I designed it in SolidWorks, printed out and put it in right here. Just hammer it to get inside this shaft, and this piece goes here, right like that, like this. And when this motor is spinning, the whole system spins smoothly. This is how we reproduce or reverse engineering this piece, put it here, and get this machine works.